Hello, everybody. My name is Josh. I am a solutions architect here at Pulumi. With me is Jay Smith from Google. Jay, if you'd like to introduce yourself to the audience.
Absolutely. So my name is Jason Smith. You all could call me Jay. I will respond to either, so don't think too hard about it. I am a senior cloud customer engineer at Google Cloud, focusing mainly on application modernization, also self-proclaimed cloud alchemist, and I'm happy to be here.
Okay, so today's agenda, here's what you can expect. First up, I'm going to show you some slides. Going to give you an introduction to Pulumi if you're not familiar. Jay is going to then present some slides about Google Cloud and the stuff that they're working on. Then there's going to be a demo for that Jay's going to be presenting for AI ML workloads on GKE. And then as time allows at the end, we will stick around for Q&A. So please get those questions ready. Feel free. Don't be shy. Ask as many questions. Whatever comes up. If whatever you're curious about. The Q&A part is also one of my favorite parts of giving these presentations. Okay, so you should have received an email that will give you an organization invite. And so if you accept that organization invite, that is there to make onboarding to get a Pulumi Cloud account as quick as possible. Pulumi Cloud is going to be the easiest way to learn Pulumi, using that as your backend. I'll get into that a little bit more in a sec. But for now, just suffice that the ask is please accept your organization invite. It's going to make onboarding much easier. Okay, so about Pulumi. Okay, so what is Pulumi? Pulumi is fundamentally an infrastructure as code tool. There's two things about it that make it unique in the IAC landscape, which is one, you can use general purpose programming languages to express your infrastructure. And we'll get into the full list of those languages and their advantages in just a sec. And two, it will allow you to manage resources in any cloud. And I will give you a full list of those shortly. And then there's two parts of the Pulumi product. There is the open source stuff, which includes like our infrastructure as code engine, our policy as code engine, all of our providers that allow you to manage infrastructure in the various different clouds and SaaS providers we support. And then there's also a managed SaaS called Pulumi Cloud. And again, I'll get into what all those things mean. But the takeaway from this slide is modern infrastructure as code using general purpose programming languages that will allow you to manage resources in any cloud. Okay, so on the left-hand side of this slide, at the top left, these are the languages that Pulumi supports. So you can write Pulumi programs in Node, Python, Go, or .NET. We also have Java support, which is in preview. And you can also write Pulumi programs in YAML as well. So what is the advantage of writing infrastructure as code in general purpose programming languages? Well, you get to use the same familiar syntax that you already know. So for example, you don't have to learn any special syntax to index an item of an array. You can just use your regular old square brackets. If you want to use conditionals, if you want to create resources under some circumstances but not others, you can just use a regular old if-else block. If you want to create resources in a loop, you just use a regular old for loop in whatever language you're familiar with. So that covers like the sort of syntactical aspects of it. And when it comes to tooling, when it comes to tooling and writing infrastructure as code in general purpose programming languages, you can first off leverage all of the IDEs that you are used to. So whatever your preferred editor is, that will just work with a Pulumi program without any additional tooling required. So if you were using VS Code, and you're going to get that syntax highlighting and that autocomplete. All that stuff is going to work just exactly as expected. You do not need to install any additional programming, any additional tooling. Then you can also leverage the ecosystems for consuming and sharing code that you already know. So, for example, if you're writing a Pulumi program in Python and you need to pull in some external data via HTTP, you can just reference the request library. Likewise, if you want to share Pulumi code, that's just a regular old, say, PyPI package. And again, this applies it's similarly for all the other languages that Pulumi supports. So if you're writing it in Node, you can share Pulumi code using npm, and you can also import npm packages into your Pulumi program. And that syntax, by the way, is also the same as would be in any other Node program, for example. Okay, so that's why you want to use general purpose programming languages. Now, when we talk about any cloud, Pulumi supports a very long list of cloud and SaaS providers. Of course, all of the major hyperscalers are in there. So, of course, Google Cloud, which we're going to be focusing on today. Pulumi also has a provider for Kubernetes. So, like, for example, using the Google Cloud and the Kubernetes provider together in the same Pulumi program is like really, really powerful stuff. So what you can do is you could spin up a GKE cluster and then deploy Helm charts onto that cluster, along with any other Kubernetes resources you might want to add. We also support a longer list of smaller cloud providers, as well as SaaS providers, including like Datadog, New Relic, GitHub, GitLab, et cetera, et cetera. At present, we have over 150 different cloud providers. And so a little bit, just a quick, so you understand like the kind of the differences between Pulumi and some of the other IAC tools that are very popular that are out there. First off, again, we use general purpose programming languages as opposed to a domain specific language like HCL or YAML. And again, those advantages: familiar syntax. You can just consume libraries that are a part of whatever that language ecosystem is. You can manage resources in any cloud, as I mentioned before. And then the way the deployment model works is when you run Pulumi programs, the HTTP request, for example, to the Google Cloud API, that's going to originate from the client machine. So if you're running it on your local laptop, that request is going to originate from your laptop. There is no centralized service where you submit your resources, and then that service does the creation or updating on your behalf, like you would see, for example, in CloudFormation. So, and the advantage of that deployment model is that it tends to execute faster. There's also, by the way, no attempt in Pulumi to transactionalize your infrastructure as code, so we don't roll anything back if there's a problem. Whatever work, if your program hits an error, whatever work that has been done is done, and whatever work remains to be done remains to be done. We don't attempt to roll back to a previous state. So that covers the deployment model. On the bottom row of this slide is our secrets handling. Pulumi has really, really good secrets handling. So I did note that we have a few folks here from the security part of the org, so this will be interesting to you in particular. Pulumi knows which of your values in your resources are secrets. So, for example, if you're spinning up a Google SQL database, it will know, for example, that SA or master password is a secret, and we will only store the ciphertext in your state file. So if your state file were to leak for some reason, you would not leak secrets. Likewise, you can also store config values as secrets. And if you flag them as secrets, we will only store the ciphertext. That means that your configuration files for your Pulumi programs can safely be committed to Git. And if your Git repo were to become public somehow, again, you would not leak secrets. And you never, ever want to commit any secrets in plain text to a Git repo, regardless of whether it is public or private. If you ever do that, by the way, you should generally rotate that secret as soon as possible. Okay, so a little bit about Pulumi's program model. At the top level, we have a project. A project is just a folder that contains a Pulumi program. So there's not that much to say about it. Your program, this is where you're going to define your resources. For example, a GKE cluster or networking resources. So in your program, you're going to define resources. Pulumi programs, by the way, are declarative. So you only need to say what the desired state of your resource is. You don't need to say, for example, create this thing if it hasn't already been created, or change it from, change my cluster from 2 nodes to 5 nodes or something like that. You don't have to do any of that. All you have to do is say what the desired end state is, and Pulumi will figure out the steps that are needed to get from your current state to your desired state. So within your program, you're going to define resources. An example of a resource might be, for example, a network in GKE. And within your resources, they're going to have inputs, which are values that you define, and outputs, which are values that come back from the cloud provider. So an example is you might define a network. Your networks in Google Cloud are global, which is one of the cool things about Google Cloud. And then you might want to define some subnets within that network. So you might want to put a subnet in one region and another subnet in another region. And so, for example, the network ID is an output, right? Because that value becomes known after you create the network in the cloud provider, and then that value will feed into the subnets that you create. So again, the output is the VPC ID, and that becomes an input to the subnets. And so what's going on behind the scenes is Pulumi's keeping track of what depends on what, and it will create or change or do whatever work needs to be done in the right order and with maximum efficiency. And it's the inputs and outputs that allow that to happen behind the scenes. So that covers the left-hand side of the slide. On the right-hand side of the slide, we have our stacks. Stacks are instances of your Pulumi program. An example, common use for stacks is you might have a dev environment and like a prod environment. Well, those would be different stacks. You can store different configuration values in your stack configuration files. They can be marked as plain text or as secrets. So for example, if you had like an API key that you needed to use, you could mark that as a secret and reference that from your Pulumi program. So example of how you might use this, like if you're spinning up, let's say, GKE clusters, well, you might want to have less nodes or less powerful nodes in your dev environment than you would in your prod environment. So you can store those things, again, as configuration values in your stack configuration files and then reference them from within your Pulumi program. So that covers the program model. The physical model, I'll go through this real quick. So again, bottom left corner of the slide, you have your Pulumi program. You can write those again in Python, Node, Go, .NET, Java, or YAML. And your Pulumi program is interpreted by the Pulumi engine. So what happens is your Pulumi program contains the desired state of your resources. The Pulumi engine will do a diff against your Pulumi state file. By default, that state file is stored in Pulumi Cloud. Pulumi Cloud will also, by default, be your secrets backend. So it will handle the encryption and decryption of secrets. And so what happens is the Pulumi engine is doing this diff between your program and the state file. It will figure out what needs to change and in what order. And the way that it does this is via the Pulumi providers. And so in this diagram, you can see that we have the Google Cloud provider and the Kubernetes provider. But again, there's a full list of 150 providers available on the Pulumi registry. So do check that out. A little bit about Pulumi and Kubernetes. So Pulumi has a lot of tooling around Kubernetes. It is very, very popular with our users and customers. So we have a Kubernetes provider that will no doubt be involved in what we are showing today. That will give you the strongly typed standard resources. So like deployments, config maps, secrets, all those Kubernetes resources are in the Kubernetes provider. You can also manage Helm charts and releases. We have two different ways of doing Helm charts. One will essentially run Helm template locally, and the other will basically do like a Helm release. We also support server-side apply. So for example, in the config map, we have a config map patch resource that will allow you to get those server-side apply HTTP patch semantics. And then you can also consume any existing YAML that you might have in your Kubernetes manifests. There's resources for that too. That is the config group and config file resource. So you can just, with config group, you can point it at a directory and it will essentially do like a kubectl apply. You'll get very, very similar behavior to that, but it'll be managed as Pulumi resources. If you are into the GitOps way of doing things, we also support a Kubernetes operator. So you can use that with from any Flux source and manage your Pulumi programs that way. And then we also have a tool called CRD to Pulumi, which so if you have any CRDs, you can point CRD to Pulumi at that, and it will generate Pulumi code for you. So you will get strongly typed custom resource definitions. So if you like what you heard, again, please sign up for a Pulumi account. You can do that by clicking the link in the email that you received earlier to join the organization that you were invited to. Pulumi accounts are free for individual use forever, and they are definitely the easiest way to learn Pulumi. So if you are learning Pulumi, please sign up for a Pulumi Cloud account. It is, again, the smoothest way to learn Pulumi. It is free for individual use forever, and you get unlimited use with that, and we will not ask you for any payment information. If you are up and running and using Pulumi and familiar with it, that might be a good time to sign up for a 2-week free trial. You can do that through the Pulumi Cloud console by creating an organization there. And we will give you a 2-week free trial that gives you full access to all of our features. And there is no credit card required for that either. And when we say that, it's like our full suite of enterprise features. So that includes like SSO, SCIM, some advanced policies, code management features, you name it, it is included in that 2-week free trial. So please sign up for a Pulumi account if you have not yet done so. Pulumi also has an AI tool called Pulumi AI. You can go there. That link is on the handouts tab. If you go to pulumi.com/AI, you can enter a natural language prompt, whatever infrastructure you want to create. You can select the language that you would like the AI stuff to be output as, and Pulumi AI will generate a program for you. Now, these are LLMs, so they are not perfect, and but you will typically either get exactly what you want in many cases. It'll just fire up, and the infrastructure will be exactly what you need. Or at worst, you'll probably get about 80% of a starting point. And then you can continue the conversation with Pulumi AI, just like you would with like other ChatGPT experiences you might be used to. And Pulumi AI will iterate upon the code that it generates. So yeah, so do check out Pulumi AI. It's a great way to find out, hey, like what does a Pulumi program look like in Go? Or how do I connect like these 3 providers in a single Pulumi program? It's very capable and very cool, and I use it myself pretty frequently. So check out Pulumi AI. All right, and at this point, I am going to hand off to Jay. If you have any questions, by the way, please ask them in the Q&A tab. I will either answer them live soon, or I will get you some answers in text, and we'll also share. We'll share all those questions with the entire audience. So, Jay, take it away.
Thank you very much. And yeah, I am here to also second the Pulumi AI. It was incredibly helpful as I was building out my demo. So it is a great tool that I would recommend. So Google Cloud, let's talk a little bit about it. I'm sure everybody here is familiar with Google as a company on some level. You've used our search engine. Some might have Android phones. You may have gotten this invite via Gmail, but we also have a cloud business similar to any of the other cloud providers. It's a managed public cloud. I want to tell you a little bit about what's different about us, because when you look at all the clouds, there's a lot of similarities in terms of offering VMs, networking, all of that good stuff. Just to give you a quick idea of what's special or different about Google Cloud is the way we treat security. So everything is encrypted at rest and in transit. We do have we do kind of work with hybrid and multi-cloud. So we understand that, people want to work with multiple clouds, or they want to work between their cloud and their own data center, or maybe they have some servers co-located or something to that effect. So we have designed solutions around that. So that way you can get the best of both or all worlds, depending on how you're trying to set up your infrastructure. We believe in fully managed stuff. We talk a lot about AI, which we're going to dive a little bit deep into, or a little bit more into a little later, about our AI and how we have contributed to it. And then, of course, a lot of what we do is based on what Google's been doing for like 25 years. So a lot of our technology best practices within the cloud is similar. So if you want to build something like Google, this is a way to do it. So one big thing I like to put out there, because I personally have been a huge open source supporter pretty much my entire tech career, long before I joined Google. And I do actually love that Google, one, is a contributor to a lot of open source projects, but also utilizes a lot of open source projects. Big reason being that, I don't like vendor lock-in. I don't think anybody here does. I don't think anybody is, saying, oh, I can't wait to get stuck with one vendor for the next 10 years. When you're using these open source protocols, it essentially allows you to be portable. If you want to move from one platform, you can do it. Like, for example, let's look at Kubernetes. Kubernetes is Kubernetes is Kubernetes. So I can move, if I'm building on GKE, I can easily move that application somewhere else. Obviously, we want you to stay on GKE, but at the same time, I do like the idea that we are utilizing open source technology. MySQL, Apache Beam, Knative. You see all the lists there, and then there's some open source projects that Google created and that we maintain. So some of you might be writing programs in Go, for example. That's a Google language, or maybe you're writing in front ends on Angular, another open source project. So I just like our commitment to open source because I personally, again, huge open source fan. I hope all of you are open source fans because we all, I think, owe our careers and our tech expertise to open source, whether we want to admit it or not. So the commitment to open source is very good. Here are some other just stats on open source projects we contribute to. We also donated some of our open source projects for what it's worth. So like Kubernetes, we built, but then we turned over to the CNCF. So now CNCF fully manages it. I personally, from my personal take, that's a good thing because I don't like the idea of like one corporation owning an open source project and then being able to, I guess, change the rules as they feel I guess, necessary or anything like that. So once you give it to a foundation, then I think it kind of stays within the community, which is a good thing in my mind. But yeah, these are a lot of projects that we have contributed to that are open source and cloud native. Some you may have heard of, some you may not have. I'm imagining most everybody here has heard of Kubernetes and Istio. You can also get started today. So if you use like your Gmail, you can go to cloud.google.com/free and sign up, and you immediately get $300 of free credits. You can use it however you want. And that way you can also just play with it, kick the tire. Now, when you run out of that $300, we do have a generous free tier that allows you to do a lot of experiments and whatnot. Per month. You can learn more about it at cloud.google.com/free to kind of learn what those tiers are. And that way, you're informed about to make sure you don't accidentally overspend and, get that credit card bill. Hey, what's this? Containers, I talked a little bit about Kubernetes, and I think why it's important to talk about that in terms of Google. Google open sourced Kubernetes in 2015. The reason why we open sourced it, or the reason why Google created it, is because internally, everything at Google is a container. Gmail, Cloud, Android, the Play Store, YouTube, everything is a container. In fact, we started using containers back in 2006. We kind of played around with it in 2004, but it became standardized in 2006 within our organization. You may have heard of Borg. Anybody here who's a Star Trek fan is probably familiar with the concept of Borg. That's exactly what it was named after. It was named after Borg from Star Trek. So the idea was, when we look at our data centers, when our data center team was looking at the data centers and how to build applications, the way we thought of it was the data center shouldn't be seen as a series of servers, but instead it should be seen as just one giant server, and then we move the technology around, kind of thing. So one way to look at it is like, we with a container, we're able to move the application kind of freely between servers, and it just treats the server, our data center, as just one giant server versus a series of servers. And that's kind of what we wanted to do. Around 2012, 2013, that's when Docker kind of came into the zeitgeist, and people started looking and seeing the value of containers. Like, oh my goodness, this is so great. Like, instead of having to make this multi-gigabyte virtual machine, I can actually just virtualize my operating system, have like, 100, 200, 300 meg application, and build it. But what wound up happening is as we started to get bigger and bigger and bigger with these applications and create more and more containers, it became a question of, well, how do we orchestrate them? Like, how do we maintain it? Like, I have 100 containers. It's impossible for me to get them to communicate with each other and figure out how to expose them and whatnot. And, you know, those of you who might remember, a bunch of different companies came out, open source projects, experiments, etc., to address that problem, or to try to address the problem. Google was kind of like, you know, we kind of solved this problem internally, so let's just take our best practices, open source it as Kubernetes, and kind of share it with the world. And the rest is history on that one. We can, you know, if you do some research, you can actually see that Kubernetes is still kind of the de facto platform for containers. One thing I also want to talk about is AI, because it is actually against the technology laws to not talk about AI in 2024. So we will talk about that also. This is an AI talk. So Google has done a lot with AI and over the history of our years. We were a data company. We still are. So we created DeepMind. Google DeepMind was like a research technology. Excuse me. And then, and I want to also mention, yes, Cloud Run. We've done a lot of talks about Cloud Run. That's another great containerized solution. We actually invented the transformer concept in 2017, which was kind of what kicked off the whole LLM thing we're seeing today. We made a language model. Then, of course, we have Lambda, which was created a while ago. Then Bard last year. And now we also have, you know, we had all these AI products, and it was kind of confusing to figure out what all they were, because you had like, oh, this is Duet, and this is, you know, this is the Palm, and this is that and the other thing. We recently rebranded everything under Gemini just to make it make sense. But then we also have an open source version called Gemma. One thing we're going to talk about is there's a lot of LLMs out there. There are the commercial LLMs, such as OpenAI, and of course, you know, Gemini and whatnot. But there are a lot of open source ones that are pretty good. In fact, if you looked yesterday, it was either yesterday or the day before, Databricks just announced their own LLM. So there are a variety of ones out there, and some of them you can actually just download and run yourself if you want to. You don't have to run them on a particular cloud or have them gate kept or anything like that. And that's kind of what we're going to look at today with my demo. Is we are going to look at how I was able to create a Kubernetes cluster that would deploy use Pulumi to create a Kubernetes cluster, GKE cluster to be more specific, and then deploy the Mixtral LLM using the Hugging Face interface. Say that 10 times fast. And run that on a cluster easily. One of the benefits here is, you know, there's a lot of managed solutions out there for AI, ML, and LLMs, and that's perfectly fine. But I also find that there's a lot of people who want to run it on Kubernetes for a variety of reasons. There's no right or wrong answer. It just depends on your use case. And, you know, if you want to run on Kubernetes, you can do that. And we will go ahead and show you how I was able to do that real quick. And one of the benefits when talking about this, as I try to figure out how to share my screen here, one of the benefits, here we go. Let me know if you can see this. One of the benefits, as we mentioned earlier,
and
about
Jay, you're going to have to make
that.
Sorry to interrupt. Yeah, Jay, yeah, a lot larger. There we go. And maybe one more. Right. Folks, if you could let us know in the chat if that is large enough. But yes, Jay, sorry to interrupt. Go right ahead.
Yeah, no worries. So you'll notice this is Python. One of the great things about Pulumi, as mentioned earlier, is that you get to use a programming language you already know. You don't have to use a specific kind of proprietary language specific to Pulumi. This is standard Python code. Data scientists out there, you all know that you use Python day in and day out to do your job when, you know, talking to AI ML. It's great that you can just go ahead and continue using Python to deploy the resources you need. So let's take a quick look around here, and you'll see that this is pretty standard Python stuff. I'm importing my models, these different Pulumi modules here. Here I actually created a separate file or separate module specifically for the Mixtral, which we'll look at in a second, which is this file here. I set a few different variables for the my project, my region, my zone, my network, what the cluster name is, cluster version, pretty basic standard stuff here. Now I actually create my cluster here, and you can see I just set a bunch of the different settings, such as I wanted to use workload identity. I want to use the GCS fuse driver. This is essentially allows me to fuse a drive to the Kubernetes cluster. That's where I'll store kind of the LLM models and all that good stuff. I can also set the scopes. I can set a bunch of different things, but as you can see, it's simple Python here. There's nothing special about it. It's just regular Python. And the documentation is actually very good for Pulumi. That helped me make all of this. So, it's just like reading the API documentation of any other program or any other Python library or Go library. This could have just as easily been written in Go or TypeScript or any of the languages Pulumi utilizes. I just want to focus on Python since that's one I'm comfortable with, and two, that is like the preferred language of data scientists, and we're talking about AI. I create a separate node pool here. As you can see, I then I mount some drives to it. I also have mounted two NVIDIA L4 GPUs. So this is going to be important for running the model. As we all know, GPUs are very, very helpful for doing AI ML work. I'm mounting two in particular. It could be more if I wanted to, but for the purposes of this demo, it is two. Latest driver, installing the driver, a few other parameters, setting it up to auto scale, auto repair. This is all standard stuff. If you're familiar with using GKE and you look through our documentation and you do G Cloud container and you build auto container, it's the same kind of tags that you would have there, just in Python. Then we create the cluster, we get the context, and that way we can deploy the application itself. Let's see here. So I'll actually show you. And this was actually pretty cool. This is something I actually just learned about. So here is the Kubernetes YAML that I use to deploy the Mixtral LLM with Hugging Face. This is probably very standard to anybody who's seen here. Pulumi actually has a this program or this function within the Pulumi CLI called Pulumi Convert, and you can actually take the YAML file and it will convert it into the Python application, a Python module that you can then import into your file and use. So that's literally what I did. I ran that. It gave me the basics, and then I just kind of tweaked it a little bit for my purposes. And so now this YAML is in Python to be used for Pulumi. And so I call it and execute it, and it's good to go. Give me 1 second. And yeah, to me, it's just super cool how it's able to work. So what I did, and you'll see, is I'll do a Pulumi. Let me see if I can share it. Give me 1 second. I have it on a completely different terminal, so apologies for that. But yeah, let me see here. Okay, pull it up. Well, let's go and actually look at the end result here real quick. So I actually ran it earlier because it takes about 15-20 minutes to actually execute and actually build. But if you run Pulumi up in the file, it will go ahead and build everything. Let me go ahead and show you what the end results look like. Let me pull up the file. Let me change the screen. Here we go. And bear with me as I expand this so that you all can see it. I actually avoided saying y'all, showing off my Texan. All right, so here's the actual cluster that I created. So after using Pulumi up, it went through the process, built the cluster with all the variables that I had. There's an upgrade available, so I'm using the 1.2, 1.27. I could have used a more recent version, but that's fine. Standard cluster, let's look at the nodes. Here's the node pool that I created. As you can see, it has the 2 NVIDIA L4s using the latest driver as I declared in the Python file. The 2 ephemeral disks. So everything I declared in Python is there. And then let's look at the workloads. And as you can see here, here is the workload that I deployed. So that is the application I deployed, and it also has the service. So if I go here, it'll pull up the website or pull up the endpoint. There is an actual way to play. You can actually now call this URL from your terminal or whatever application you're writing, and then send code to the LLM. This is the endpoint for the LLM, and then there's different verbs you can use. So / I think demo and / whatnot. So now I actually have a full LLM deployed using Pulumi, and I actually don't even have to go to the terminal to do any of this. I could just, I could easily do this with the terminal, but I was able to actually do it with Pulumi and deploy it as. So if I'm a data scientist, for example, I'm using Python, I need to deploy something for my language or for my purposes, for LLMs, for developing something. I can do it with using the Python programming language, continuing my existing workflow without having to do much disruption or becoming a Kubernetes expert. If you're a platform engineering team, you can provide these modules or create some Python models to be used, or excuse me, modules to be used internally that can then make it even simpler for your people to deploy. So this is, to me, just a really big game changer for a lot of people. I don't know if any of you remember, like a few years ago, there were a few different open source programs trying to do the exact same thing of simplifying the deployments or simplifying the use of Kubernetes for machine learning specialists, for data scientists. That's what I'm looking for. So such as Kubeflow was used, because the idea was, well, data scientists don't want to become Kubernetes experts. Kubernetes is a great platform for doing LLMs or ML, well, not LLMs at that point in time, but for using ML and AI and whatnot. But data scientists don't want to become Kubernetes experts, and that's a very reasonable expectation. So Kubeflow tried to simplify that. I would argue that using Pulumi, which allows you to continue using your Python language skills or whatever language skills you choose to use, helps even more with that. Like, it helps simplify the process even more, because now I can just I can build it into my pipeline, my ML ops or whatever, just writing the program. So I will turn it back over to Josh to talk a little bit more about Pulumi, and I will actually look through the chat.
Yeah, so Jay, we do have one question in there that was, what do you mean when you say you've deployed the workflow, or was that workload that you said?
Workload, yes. So the workload is like within within Google Cloud, we use the terminology workload, and that refers like a deployment, a daemon set, those type of Kubernetes modules. So when I say I deployed the workload, I deployed the Kubernetes, that's the word I'm looking for. So let me actually show real quick, just to help show that. So you'll see here that this basically there's 2 different parts to this. There's a deployment, so an application deployment, which if we look here to something more familiar to people, the Kubernetes YAML, you'll see that this is the deployment that deploys Mixtral. We pull the Hugging Face interface here. We pull a specific module, the specific version of Mixtral. There's some other parameters here that are specific to the Mixtral, but you can read the documentation. They'll go into bigger detail. Now we also have a service. This is what actually exposes the application. I'm using a load balancer. I know best practices in the past year or 2 has been to use the Gateway API, but for the purposes and for simplification of this demo, using a load balancer service. So that's deployed too. So this is the deployment is the workload. That's like the actual application that's running, and then we have the service that is exposing it.
Cool. Jake, are there any more like Kubernetes resources in the code base that you could show?
Let me see. So I think I probably showed all of them, but there's a lot, or for the purposes of this demo, I showed all of them. But there are, I mean, as far as I can tell, reading through the documentation, anything that's Kubernetes related can be Pulumi supports. Like I can deploy.
Definitely. And one of the most advantageous things about Pulumi, and particularly for Kubernetes, and I did mention this in the chat, but I figure it's worth saying on mic as well, is that with Pulumi, like you can define your cluster, for example, GKE, and then deploy resources onto that same cluster in the same Pulumi program, and that is something you can really only do with Pulumi. So you know, that's like really one of like the best ways to use like, you know, Pulumi with Kubernetes is to do it that way. Again, because that is only possible with Pulumi. So yeah, you might want to deploy your cluster, then you might want to install a Helm chart or other resources. You might want to deploy a config map or something like that. You know, all of the Kubernetes resources are available in the Pulumi Kubernetes provider. Yes, and this is exactly how you do it. Is you create. Yeah, this is what's called an explicit provider. So so there's this concept of like a default provider that you don't have to actually declare in your program. It will grab its config from your like operating system. So it'll be like pretty much like whatever credentials like G Cloud, the CLI tool, would use, Pulumi will use by default. But then there is also this concept of a default provider. And so you could use this, for example, if you wanted to do like multi-region deployments. You can use explicit providers, and this is also how you because like the Kubernetes provider will also use the default configuration from your operating system if you're using the default provider. So it'll look at essentially your kube config and be like, okay, what's the active configuration there? But you can also declare an explicit provider, which Jay is doing on line 120, and pass it a kube config, and then for all resources that you want to use that provider, you can assign the provider to the resource. So you could do really, really powerful things like this. Like if you're deploying multiple federated clusters, you can deploy, and you want to deploy the same thing to each cluster in a loop. Well, you could create a for loop if, let's say, you're deploying a config map or a Helm chart, and then just loop through and just create a resource for each cluster that you want to manage, all with its own explicit provider. That might be a little bit to follow just in words rather than code. But I can also sketch this out if anybody wants to see it. Just ask in the Q&A tab, and I could sketch that out roughly to show you what it looks like.
Yeah. So basically, you can see here. So I had the provider over here called kubeconfig. So I basically tell it that, hey, use this provider to deploy the application. So now it can deploy this deployment onto that specific Kubernetes cluster.
Right. And then there's also, so that is the resource options. Every resource accepts resource options. There's a lot of different things you can do with that. You can, again, specify an explicit provider. You can protect things from being deleted. You can specify explicit dependencies. You can even write functions that will transform the resource. So like you could write a function somewhere that like adds tags if they're missing, and then you can like reuse that on every resource. So it's super, super powerful and super helpful. So again, no questions right now, but if you have anything you're curious about, please ask away on the Q&A tab. We do have some more time. So I am going to talk a little bit about some of Pulumi's more advanced features for platform teams. So Pulumi has this API called the Automation API. So normally when you run a Pulumi program, you're going to use the Pulumi CLI to do something like, run an update. That's the Pulumi update command. But what the Automation API allows you to do is to flip that dependency and embed all of the Pulumi CLI capabilities inside a regular old, let's say, Python program. So like, why is that helpful? Well, for example, you can use this to make like a simple CLI tool that will initialize like temporary environments for your app teams to use, or maybe even your sales team. And then they can just run one CLI command to, like, for example, spin up an environment, let's say for a sales demo, and then another command, just pass it a different flag to tear it all down. And so like basically all the CLI commands in the Pulumi CLI, whether it's like managing stacks or configuration or whatever, or spinning up infrastructure or tearing it down, you can reference all that stuff via an API. And so that is our automation API. By the way, it is totally open source. It's definitely worth checking out if you are interested in some of the more advanced features that Pulumi provides. Pulumi also has a policy as code engine that I really, really love and can't stop talking about. It is open source. Basically, the way it works is you write functions that will either validate individual resources, or if you need to validate multiple resources at the same time. So, for example, if you have like a storage bucket and you need to set up replication on that, so you need to look at multiple resources at the same time, you can validate the entire stack. And so like those are the different types of policies you can write. You can we have a set of compliance ready policies for the major cloud providers, including Google Cloud, that have policies set up for you to validate your resources against common frameworks like PCI DSS, ISO 27001, and CIS as well. You can write policies that attempt to remediate the issues that it finds in line. So you don't have to just, for example, fail if tags are missing. You can instead add those tags and then validate. So those are called remediation policies. And there's also a paid feature for server-side enforcement. So if you are running Pulumi policies using open source, you will just pass through the path on disk to the policy pack. But the paid version of this feature allows you to centrally manage which policies apply to which stacks. So if you're part of the security org, you can go in and create what's called a policy group and say, I want these policy packs to apply to these stacks, and that will be enforced from the server side, no matter where you are running Pulumi. When you run that Pulumi command, it's automatically going to check with Pulumi Cloud and say, I need to run these policy packs. It will download and run those packs no matter where your Pulumi command is run. There's also a tool we have that's pretty new. It's called Pulumi ESC. It is, I frankly struggle to describe it a little bit concisely, but basically what it does is you can define environments. Environments are groups of config and secrets, and those secrets can be dynamic secrets like OIDC creds, or static secrets like, say, an API key. And then you can write this like YAML configuration file. It's hierarchical, so you can compose environments at like different layers. And essentially, these environments are going to either be passed directly to your Pulumi program, or you can pass them as environment variables to execute any arbitrary shell command. And so, essentially, what this is this is like our answer to the problem of like when you start using IAC at scale, you get a lot of secrets and configs sprawl, and you end up having to repeat like the same values in a lot of different places. And Pulumi ESC allows you to sort of centralize that management and also to create composable environments. Pulumi Cloud, by the way, also has a managed CI/CD feature called Pulumi Deployments. We do give you some of this on the free individual plan, so you can check this out. Essentially, what it does is it allows you to streamline your CI/CD pipelines for your Pulumi projects. So do give that a check out. And there's some, can't tell you too much about it, but there's some really cool features that are going to be added down coming soon that are going to make some very common scenarios really easy for folks to implement. So again, one more time, if you have not yet created a Pulumi Cloud account, I'd strongly encourage you to do so. Again, free for individual use forever. We don't ask you for any credit card information. It makes learning Pulumi way, way easier. So there's really no downside to that. And then again, if you are up and running using Pulumi and you think that you might like to have your team or organization start using it, that's a great time to sign up for a free trial. It is 14 days. You will get full access to all of our enterprise features. And again, no credit card required for that as well. Yes. So if you would like to join us for an upcoming workshop, we have some goodies coming up, some bangers, if you will. So tomorrow, my colleague Diana will be leading a workshop that demonstrates how to do CI/CD for GitHub Actions. Now, the title of this does include AWS, but this will be perfectly applicable for your Google Cloud infrastructure as well, because the main focus of it is like, here's how you create CI/CD pipelines for Pulumi programs in general. So if you want to join us tomorrow, that's coming up. Next week, I'm going to be doing a similar workshop that's going to use GitLab. So I will be exploring all the different ways that you can use Pulumi with GitLab, including ways to make generating pipelines a lot faster by using Pulumi itself to create repos and to add the pipeline definitions in your repos. So do check that out. And then also, so that's coming up next week. And then later on in April, we have an intro to getting started with infrastructure as code on Google Cloud. So if like, if this workshop, if you're not as familiar with Pulumi and this workshop was helpful for you, what we're going to be showing in that workshop coming up on April 24th is we will be showing you basically how to like start from scratch with a very, very detailed explanation of like how you write Pulumi programs from scratch. And we're going to be doing, I'm guessing, probably at least 2 different examples of that. So do join us for that as well. And again, all those workshops are starting at the same time. So you'll know when to join us as well. So again, if you want to see all of our upcoming workshops, you can head on over to pulumi.com/resources and the full list will be there. So check that out. We would love for you to stay, to continue the Pulumi journey. So again, first thing to do, if you haven't yet done so, I know I've said this a few times, but I just want to make sure everybody hears it, is to sign up for a Pulumi Cloud account. There's a link for that on the handouts tab, or you can click the invite to an organization that you got in your email. You can do that there. Second, I'd like to urge folks to try Pulumi AI if you've not yet done so. It is free to use. It is based on ChatGPT 4, and you can do that at pulumi.com/AI. That link is also on the handouts tab. And then third, if you are interested, if you want to like interact with some members of the Pulumi community or Pulumi employees such as myself, please join the Pulumi community Slack. You can do that at slack.pulumi.com. That is also, of course, free. And there's a very large community. There's tons of channels in there, pretty much for whatever you want to ask questions on. So unless there are any further questions, and I don't see any, I would like to thank everybody for taking the time that you spent with us on behalf of myself and Jay, and we hope you have a lovely rest of your day. So long, everybody. And again, thanks for taking that time to join us.